All right, so let's go very slowly through how we find the intervals of increasing and decreasing. So remember that for increasing, we want to know where our derivative is greater than 0, and for decreasing, we want to know where our derivative is less than 0. So it becomes a question of solving that inequality. To do that, our first step is going to be critical numbers. Now, remember with critical numbers, technically, you need to think about the domain of the function. And here, remember the domain is all reals unless you have a problem. So the problems being denominators and square roots. So when you look at this function, you don't have a denominator, you don't have a square root, so you are what we call problem free, and that means our domain is going to be all real numbers. So that always brings a smile to your face when you know you have no problems in life. The denominator, the square root, there's no issue there, so you're looking at all reals. All right, so then you look at where your derivative is equal to 0 or does not exist. All right, so we're going to take our derivative. All right, so this is kind of a weird looking function. They have 3 terms and there's a lot of negatives here, but that's okay. All right, so the first term, -1/4, that is a standalone constant, so it's going to go to 0. The second term, 5v to the first, linear term, so its derivative will be the coefficient. The third term, the 7/2 will tag along, and then the 2 will come down, and then subtract 1 from the exponent. Now, of course, those 2's are going to cross out, and so I'm just looking at a derivative that is -5 minus 7v. So to find the critical numbers, I'm going to set that derivative equal to 0 or derivative does not exist. Now remember, the does not exist is about, do I have a denominator? And if so, then I set it equal to 0. In this case, my derivative does not have a denominator, so I do not need to worry about that second condition. I just have to worry about the derivative equal to 0. All right, now you'll notice here, this is not an equation we need to factor. The highest power is 1 here. And when the highest power is 1, that's a linear expression, and you can simply isolate the variable, in this case v. All right, so we do not need to factor. If it had been a quadratic or higher, then we would start thinking about factoring. But here, I just have that the highest power is to the first power, so I can isolate the variable. I don't need to do any factoring. So to isolate v, I'm just going to undo PIMDES. So I'll add 5 to both sides and get -7v is equal to 5, and then divide by -7 and get v is equal to -5/7. Now, please note here that you can write it like 5 over -7, or you could put the -5 in the numerator, or you could write negative fraction and then 5 over 7. So we only distribute that negative to either just the numerator or just the denominator. All right, but I like to just put the negative right in front of the fraction bar as my representation, but these are all technically the same number. All right, so this -5 over 7, that is a critical number. Again, our domain was all real numbers, so we did not have to worry about any interior point not being actually interior. So this is our critical number. All right, so we set our derivative equal to 0. We got this critical number. Then our second step is going to be to draw the derivative number line. So I'm going to draw my number line here. And remember, why are we doing this? We're doing this because we're trying to figure out where the derivative is greater than 0 and where it is less than 0. So we are going to plug into the derivative. So again, we're plugging, let me write this here. We're plugging into the derivative. All right, so we have our number line. We have our one critical number, which we're going to label is -5/7. So that divides us up into two intervals to test. We have our first interval that goes from -infinity to -5/7. And then we have our second interval that goes from -5/7 to infinity. And we're going to plug in to our derivative. All right, now you do all of this work and it's like, where is my derivative? Like, where do I need to plug in? You're plugging in to that derivative that was right before you set it equal to 0, or right as you were setting it equal to 0. So you'll notice here where I set it equal to 0, that is my derivative definition that I want to go back to. Okay, so right where I was setting it equal to 0, that's where I'm going to plug in. All right, and again, I'm going to just pick any number that I want to that is to the left of -5/7. Now, here's the deal. Like, I might decide I really want to plug in -10. Somebody else might decide they really want to plug in -3. Because everybody's going to have a different opinion about what number to plug in, we are not going to put that number on the number line. Because again, I might plug in -10, someone else might plug in -3, someone else might plug in -100. It's all up for debate as far as what number you want to plug in. So the key thing though is that you do have to plug in a number that is to the left of -5/7. So like if you were to plug in like -0.5, that would not work. That is not to the left of -5/7. All right, so I don't know. Let me plug in -2. Okay, so if I plug in -2, I have -5 minus 7 times -2. All right, now you can put this in on your calculator just as it is. The key thing is you have to put it in on your calculator correctly, though. You cannot be like me and put it in incorrectly. So you have -5. Let me do this again. So we have -5 minus 7 times -2. The thing is, just like in college algebra, when you get this plus 9, nobody really cares that it's 9. They just care that it's positive. Because remember, like I might plug in -2, someone else might plug in -3 and get a completely different number. So it is important that you just write the plus sign, that you don't start talking about how it's 9 or 12 or whatever. So I'm going to put a little plus sign here. And what does that plus sign tell me? That plus sign tells me that my derivative is positive. So that means that I'm going up a hill. And I always draw like a little line here just to show that yes, I'm going up the hill. All right, now I also have to do this for the second interval. And again, I can plug in any number I want to as long as it's to the right of -5/7. So maybe I plug in 0. Right. Now again, you can do that on your calculator or you can just do the mental math of it. It's going to give you -5 and that gives you a negative. And again, you don't really care about the fact that it's 5, -5, you just care that it's negative. So that gives you a negative. And what does that negative tell us? That negative tells us that the derivative is negative. So that means that we are decreasing. So again, when we have our derivative is positive, we are increasing. When our derivative is negative, we are decreasing. So when I get this plus, that plus means that I'm going up the hill. When I get this minus, that minus means I'm going down the hill. Now, to write your answer, what we're going to do is remember increasing and decreasing always have parentheses. So we're going to say that it's increasing from parentheses -infinity to -5/7. and then it switches to decreasing on the second interval. So negative 5/7 to infinity. All right. Now, the cool thing about this is that once you know where it's increasing and decreasing, you can then determine where you have a relative max or min. So if I just showed you a picture like this, hopefully everybody would agree like this point is a relative max. It's actually the absolute max because it is the highest point. Now, that's exactly what we have here. We have a peak. We have something that's going up and then something that's going down. So what we can say is that there is a relative max at negative 5/7. And that's because when we look at kind of like this rough sketch that we have, we're going up and then we're going down. So that critical number is our relative max point. Now, the relative min, on the other hand, is not happening for us because we don't have a valley. We don't have a small point. We have something that just continues going down, continues going down. So there would be no relative minimum. Now, you'll remember that for the relative max, if it says at, the whatever follows is understood to be a x value. However, there is a little bit of an issue here with like the way that the homework software is presenting this here. So it says determine the value of the local max, and then it says enter the solution in point form. So they actually want the coordinate for it. So here's the deal, you guys. What our process was is our first step was we found our critical numbers. We set it equal to 0 or does not exist. Then we draw the derivative number line. Again, plugging into the derivative. And then our third step to find that relative max or min point. How would we do that? Because that's what the homework is asking for us, is how do we find the point? And to find the point, remember a point is always a point, an x comma y. You know the x value. You know the x value is negative 5/7. To find the y value, you are trying to find the y coordinate. That is the original function that you are going to use. So when you are trying to find a point, you are always going to plug into the original function, not the derivative, but the original function. So the original function for this problem was this negative 1/4 minus 5v minus 7/2 v squared. So what I'm going to do is everywhere that I have this little v, I'm going to plug in the negative 5/7. So I have negative 1/4 minus 5 times, and for v, negative 5/7 minus 7/2, and for v, negative 5/7 squared. All right, so you can then go through the arithmetic of this, and that is fine. I mean, you can go through the arithmetic of it, but it's going to involve like getting a common denominator and so on. You are allowed a graphing calculator, and I might do an arithmetic question in the next video here, but you are allowed a graphing calculator, so you could put this in on your graphing calculator. If you do that, I would just be really careful with your parentheses. So put parentheses negative 1/4 minus 5 parentheses negative 5/7 minus, and then I would make sure to put parentheses here so that that is all multiplied by the negative 5/7 squared. And you'll get some crazy decimal. Then remember you can hit the math button followed by number one fraction. And if it's possible, it will convert it into your decimal approximation to your fraction that they want, because they do want a fraction. Okay, so that's where you would get the 43/28. So your point again would be this. It would be the negative 5/7 comma 43 over 28.